Hello, and welcome to Unit 2 on position, velocity, and acceleration. In the first part of Unit 2, we are going to introduce the concepts of position, displacement, and distance. Position is the location of an object in a coordinate system. So here, for example, I have an object. Before I can describe its position, I need to set up a coordinate system. So here I have a standard XY coordinate system. And let's see, how many did I draw? 1, 2, 3, 4, 5. I can now say that the position of this object, which is usually given by R, is at 5 in the I hat direction. Okay. If I set up a different coordinate system, 2, 3, 4, 1, 2. Now the position of the object is at -4 in the I hat direction and at -2 in J hat. Okay. As you can see, the position very much depends on the coordinate system. Everybody could have a different position because they define their coordinate system differently. On the other hand, if we look at the displacement is a change in position, and displacement does not depend on the coordinate system. Okay. Displacement is calculated by taking the final position minus the initial position. Okay. So here I have two positions. I'm going to let this one be the initial position, this one be the final position, and I'm going to define a coordinate system such that my y-axis goes straight through those two. And let's make our lives kind of easy. 3, 4, 5, 6. So I see that the final position is now 6 j hat, and the initial position is at 2 j hat. Therefore, the displacement is going to be 6 j hat minus 2 j hat, or in other words, 4 in the j hat direction. Okay. If I were to draw this as a vector, it would be this, and we see it's 1, 2, 3, 4 away, and it goes in the positive direction, so it is all consistent. Okay. Displacement is a change in position. It only depends on the endpoints of the motion. Nowhere in this example have I described or defined what path the dot took to get from its initial position to its final position. The displacement magnitude is the distance as the crow flies. It's the straight line distance between those 2 points. Distance, unlike position, unlike displacement, distance is a scalar, and it depends on the path that you take to get from one position to another. If I go from my initial to my final along the straight line, that distance would be the magnitude of my displacement. But you could also imagine taking a more circuitous path, in which case the distance you traveled to get from your initial position to your final position would be much larger. Again, distance is a scalar, which means it doesn't have a direction, which means all distances are going to be positive, or if you want to think about them as unsigned numbers. Okay. In physics, a positive sign indicates a direction, a negative sign indicates an opposite direction. Distance is a scalar. It doesn't have a direction, therefore it does not have a positive or a negative sign associated with it. The last slide in this section consists of two questions. Can the distance an object travels be zero while the displacement is non-zero? If we think about displacement as a change in position, if displacement is non-zero, that means that this doesn't equal zero, which means I have to have traveled from an initial position to a final position. And because I have to have moved, I have to have traveled some distance. So can distance be zero while the displacement is non-zero? The answer here is no. Can the displacement be zero and the distance non-zero? Okay, so let's go back to here. And the first part of this says our displacement equals zero. Well, that means that our final position equals our initial position. One possible case is we didn't go anywhere. That would certainly meet this criteria of final position equals initial position. But another way to get that criteria met is to travel in a circle or any round trip that you might imagine. If you travel in a round trip, you will have gone somewhere and therefore traveled a distance, but your displacement will be zero because your final and initial positions are the same. So the answer to the second question here is yes. Distance can be non-zero while displacement is zero. This concludes this part of Unit 2.